Alright, let's continue our review, and we are going to review simple linear regression. Of course, simple linear regression do have sort of assumptions. So if you ask certain assumptions or under what circumstances will this regression exist, will this regression is correct, you can always remind yourself that is the test of simple linear regression's assumptions. So we have 6 assumptions. I'm not going to write it one by one, but just give you a generalized idea of what's going on. So assumption, we do have 6. One is that of course, there is the linear relationship between x and y. Of course, if there isn't simple linear, not simple, but just a linear relationship between x and y. If there isn't, you can't do the linear regression, right? So this is the first assumption, and I think that's a basic assumption because you are using the simple linear regression, and of course, if there is no linear relationship, you can't possibly do the simple linear regression. Okay, so the second assumption is that x is uncorrelated with the error term, which means that the x and the error term epsilon, its correlation is 0. All right, you can't possibly have the correlation of x and error term because you know that error term is just error. Okay, just some random number that appeared out of nowhere that you must put that somewhere, so you just put that at the error term. If the error term have some correlation with the x, say that we have a very positive correlation with x, which means that it's not the error term anymore, it's just something that correlated with x, so become an independent variable. Okay, so this about the correlation. And the third assumption is, of course, the expected value of the error term is absolutely 0. All right, so because it's error term, most of the time we just use the distribution to represent the error term. If I'm using a computer modeling program, we usually use certain distribution for this random number generating. Most of the time is a normal distribution. So for normal distribution, the mean of normal distribution, of course, you can say that the expected value of the normal distribution is 0. So that will be our attribute of the error term, because this is not if it is not 0, if it is 1 or some number, you will always have a certain number here, which will give you a biased regression model, and you can sort of think the error term as the intercept. Okay, the error term is no longer error term, but rather become an intercept, which is not correct. Okay, this is the 3, and here we go. We have 4. The 4 is the variance of error term is constant. We sometimes use the very strange word, but I think you need to master that. Is the homoscedasticity, which means that the variance of error term is constant. You are not going to get the variance term really little variance, a really big variance at that time. If you just cut the variance here and variance there, is not definitely not constant. So we need kind of need to have this constant error, constant constant variance all the time. And let's look at the 5. 5 is the error term is uncorrelated. We can't have this serial correlation problem. So if the yesterday's error term is correlated with today's error term, for example, we got positive correlation, so the error will be like this. So all the way up, right? Because once it's positive, is always positive, right? And if it's negative correlated, we got this positive, negative, positive, negative, positive, negative, something like that. And of course, this will also cause the variance not constant problem, so it will violate the 4 as well. And that is 5. Got the final is the error term. It's of course normally distributed, and as I said, at 3, the expected value of the error term is 0, and if it's normally distributed and have a mean of 0, that's pretty much the basic attribute of normal distribution. So you can memorize this as the arrow term is some distribution, and of course it's normal distribution, so have a mean of 0, and you can just kind of get all this attribute of arrow term into one distribution in order to save a little bit brain space. Okay,